Okay, all of you require data at the same time. Okay, now okay, now so want to tell you about the amplitude modulation. What is the amplitude modulation? Okay, actually, in this chapter you will learn on introduction, principle of amplitude modulation, amplitude AM transmission technique, and also comparison of single sideband transmission to conventional AM. Okay, basically, before we start, it's at pages. Okay, basically, before we start, I want to tell you something about signal. Okay, signal. This is the signal. Okay, okay, one signal, and then we got second signal. Okay. Now, so want to tell you something. What is the difference between A and B signal? Okay, this one in terms of time. Okay. What is this one is your amplitude, your voltage. Here is your voltage. Voltage. Here also voltage. Okay. Now, tell me, what is the difference between signal A and signal B? Tell me lah.
The frequency, sir.
The frequency. Okay, so basically, I want to tell you something. Frequency. If you see frequency B, signal B means frequency is high. Okay, frequency at signal B, high. Frequency at signal A, low. Okay, based on the figure first. Okay, so this signal, let's say I put here for signal A, I put 5 volt. Here, negative 5 volt. Okay, before we start. Okay, from origin, I change color. From origin to here, what we call V apa? V peak or V peak to peak?
V peak.
V peak. Okay, and then from here to here, V peak to peak. Okay, peak, not peak. You know peak and peak. P-E-A-K, no P-I-G, Okay, now very low and high. Okay, now that's the thing. And then before we start, we got the mathematical equation. Okay. Normally for this signal, I'll tell you something. Okay, this signal for amplitude modulation. Okay, for amplitude modulation, you should know something. High frequency related with F carrier FC. Okay, and then low frequency related with F input, F audio, F M. All are the same term. Okay, F input, F audio, FM. Simple thing. That's why before we start, understand this thing first. FC is fixed. Okay, now how about the mathematical equation? Okay, let's say for input, V input T. Okay, in this case equals to VI sine omega I T. Okay, in term of T, Okay. Omega, what is the omega? Omega I T. Omega equals to what? Omega I equals to 2 pi F input. Okay. Also, sometimes we put FA, FM. Okay, so clear. This one V input. How about the FC? Mathematical derivation. So now you see, this one look narrow. Narrow means higher frequency. You see something like wider here, become input. Okay, input signal. So basically known as input signal here. Okay, And then how about here? This one, carrier signal. Okay. Now, how about the derivation for mathematical modeling? V C T equals to VC sine omega C T. Okay, so how about omega C? Omega C equals to 2 pi F C. So, everybody clear at this point? Before we start do amplitude modulation. Clear? Okay.
Yeah.
This thing, okay, this thing with the time, we call this thing as a time domain. Okay, time domain because of what? When you see this, for example, the signal, okay, here in terms of time, that's what we call domain. Okay, okay. Now let's add more pages before we start. Hmm. Okay, time domain. Now amplitude modulation. We go to amplitude modulation. Okay, in amplitude modulation, actually we got input signal, and then carrier signal. How to spell carrier? Sometimes they also carrier signal, and then here is the AM signal. Okay, or output signal. Okay, so what is the in the middle? This one is a modulator. Okay, if you see in YouTube, sometimes it's called mixer. Okay, what is the function of mixer? Okay, function of mixer combine. Okay, combine input signal and carrier signal. Okay, combine input signal and carrier signal for suitable AM transmission. Okay. Now, before we start, you must know how to draw. Okay, this is the thing that sir say. Normally, student easy to understand what I'm telling because you understand the concept. Okay, input signal. You must draw like this. Okay, you know this is a low frequency, and then carrier signal. How about the set carrier signal become a lot of signal, but for um, the amplitude same, amplitude same. Okay, amplitude same. Okay, this one high frequency. Then how to draw AM signal? This is last time you see something like actually the signal of the AM signal like this. Okay, when you see the something like this. Now so you know how to draw. Okay, this is the AM signal. Okay. Actually got the mathematical, the math equation similar like input and carrier signal. Okay, now don't scare. Okay, let's see example. That's why I'm telling you something. This subject very interesting. That's why sir jump under communication chapter because I love this thing. Okay, now let's look whether you can answer or not. Okay, example. Okay, example. This one without you know about the formula of AM signal. Okay, let's say. Okay, this is the normal question they were asking you. Okay, now let's say input signal equals to 15 sine 2 pi 1500 t. Okay, input signal. Okay, or in mathematical like this lah. Better I write so that you clearly. Okay, input signal put like this lah. V, sometimes can be I, T, up to the question lah. Okay, that's as what I mentioned before. Sometimes can be VI, VM, sometimes can be VAT, okay, or sometimes VI, the input. Okay, same meaning. Okay, but right now, so I want to tell you something. This value, omega or frequency? Omega or frequency? 1500 before we start.
Frequency.
Frequency, remember, because of what? 2 pi omega equals to 2 pi f. Some students don't understand this. That's why sometimes, if you don't see here, for example here, sometimes in question, I don't put here this thing. Okay, now, this one omega or frequency? This one. If I put, now I put enter 15 sine 1500 T. This one 1500 omega or F frequency?
Omega.
Omega.
Omega. That's why I'm telling you something. You come to my class, you will get something. So right now I put 2 pi. 2 pi C. Okay, now. How about the second one? VCT. Means carrier. Okay, carrier. Carrier is 60 sine, okay, 2 pi, okay, 100,000 T. Okay, 100,000 T. Okay, now, basically, certainly something, right? You know that this question we're asking you first, sketch, S-K-E, S-K-E-T-C-H, sketch the input signal. That's why, so want you first, at this stage, sketch the input signal. How to draw? That's why I'm telling something. Basically, you must know this is mathematical thing. So, for input signal, you draw this thing. Okay. So, because you know input, input means we are using low frequency. So you cannot, if you draw like this, wrong, because this one for carrier. Now, you got the input signal. Okay, let's say sketch the input signal. You got 15, right? So you draw. How to draw? Yeah, and then this one voltage V. This one in terms of time. This is time domain. Time domain. So the frequency here. What's the value here? This one, 15 and minus 15. Easy or not? Easy or not? Okay, so you already know this thing. Sketch the input signal like this. Okay, second question. Second question, sketch the carrier signal. Okay, carrier signal similar, but since carrier signal we use high frequency, okay, so signal will be like this. Okay, a lot of signal, but the height is same. So how about how to draw? This one become 6 T here, negative 6 T. Sketch the characteristic signal. Okay, you manage. Okay, how about let's say number one? I said okay, I give this thing. What is the mathematical equation? Math equation actually V input T equals to VI sine this one 2 pi F I T. Okay. Here, math equation VCT equals to VC sine 2 pi F C T. Easy. Okay. Now. Okay. Now. For example, here high frequency. Okay, now we already solved question number 1 and question number 2. Okay, now how about sketch the modulated wave? Number 3, sketch the modulated wave. Okay, modulated wave mean AM signal. Okay. Now, how to draw before we start? Today we want to something like you recognize how to draw. Okay, basically how to draw AM signal. Okay, draw like this. Certainly something before. Don't worry, I will recap back how something like how to draw after this. How we solve the modulation index and so on. I show you after this. Don't worry. Basically how to draw something like this, and then something like this. Okay, and then this is signal inside here. Okay. Now still not derive the AM signal. Okay, now how to label? How to label? How to label? Okay. Here, okay, you see your input signal. Your input signal 15, 15 sign, and also this one is amplitude. Amplitude voltage lah. Okay, 15 and 60 is a voltage. Okay, this one VM, this one VC. Okay, one rules you must know for AM. Okay, V is bigger than VM. Number one. Number two, FC must bigger than FM. This is basic concept. Okay. Okay then, how to draw this thing? Okay. Now basically you must know something. In mathematical equation, you must know Vm plus Vc. Okay, first, Vm plus Vc equal to what? What is the value of Vm? 15. 15 plus 6, 60. Okay. And then you must know Vc minus Vm. Okay, Vc minus Vm. 60 minus 15. So you got 75 and also 45. Okay. So how to draw? Before we start, this is introduction. How you draw? Okay. So this one, okay, this one is 60. Okay. So negative 60. Here is 60. The peak one here is 75. Okay. VC minus VM, VM plus VC, VC minus VM. So here the lower part is 45. Okay. Wait. Here. This one actually 45. Okay. This one 45. Negative 45. Here. 75. Don't worry. I will give you the nice figure after this. Okay. So basically, this is how to draw the AM signal. AM signal. Okay. Okay. So question number 3. Normally they're asking you. This one I'm telling you what we will see in AM signal. Okay. Basically they're asking you about find A, B, C sketch. Okay. D. Find the modulation index Okay. Index and um, percentage of modulation. Percentage of modulation. This is normally they asking you. Okay. So how to solve it? Okay. Modulation index. This is new term you must know. M equals to V M over V VC. Okay. This is M. The big M is the percentage of modulation, means small m times 100. Okay. So in this case, um, in this case, okay, in this case, Vm, what is the Vm? Vm is the amplitude. Amplitude equal to 15 divided by 60. Okay. So you got a modulation index equals to 1 divided by 4 equals to 0.25. This one small m, modulation index. If big M equals to 0.25 times 100%. Now you don't right now we still don't go to the next slide. Introduction. I give you something like introductory things. Okay. So after you got this thing. Um now so want to tell you something. Okay. So the next question, find the F input and F carrier. Okay. How to find the F input and F carrier? Okay, you see back this question. Okay. VMT given, this is input signal. And then VCT, this is VCT. Okay, so telling something. Find the frequency of the VM. Okay, FM, the FM. FM equals to, you take back this equation, write down back. Find the FM, sorry, FM. FM and FC. So, take out the equation back. VMT equals to VM sine 2 pi FM T. So, take back the equation. What is the equation? Equation 15 sine 2 pi 1500 T. Okay, so basically what is the FM from this equation? FM, VM equals to 15. Okay, this one VMT. Okay, FM equals to 1500. Okay, find the FM. And then how about the FC? Find the FC. Take out back the equation of VCT carrier equals to VC sine 2 pi LCT. Okay, take back the equation 60 sine 100,000 T. Okay, so basically VC equals to 60 volts, and then FC equals to, what is the FC? What's the value of FC? So I did write down. What is the value of FC? Sorry. 2 pi. Sorry. What is the value of FC?
100,000.
Very good. That's what I'm telling you. You are very good. 100,000 Hertz. Please, for those who want to turn on microphone, please say inside yourself. Tell something 100,000. 100,000. Don't silent, just copy. It's not working. Okay. So this, don't worry, I give back. This is in the nice form. This one is something like in terms of before we start. To tell you actually, you don't see any slide, we managed to solve it. Okay. Okay. Then We already find the FAFC. Another one. We will find. Okay, this is the nice thing. Okay, the upper one, the analysis that we already done. Actually, we call it as a time domain. Okay, domain. How you know? You want to know time domain? See here. This one show you time, and then here also time. Okay. Now, we go to the second part. Time domain we already solved. We go to frequency domain. Frequency domain. Second part analysis. Okay. Frequency domain for amplitude modulation. This is new thing for you. Okay. Okay. This one you must copy out. Okay. Here we got something like F carrier. Okay. This one is F upper sideband. Okay. Upper sideband. Upper sideband. Here we got F lower sideband. Okay. Frequency of lower sideband. Lower sideband. Okay. So what's the formula? Okay. Now, some of you said, sir, why we need to study frequency domain? Frequency domain related with the power analysis. This is the related power analysis. Okay. Related with power analysis, related with bandwidth. Okay. Then from here, actually, this one we can also describe as a power power sideband. Okay, seems something like this. Okay, total power transmit. Okay, now P total, telling something, P total equals to P carrier, okay, plus P upper sideband plus P lower sideband. This formula you copy out, don't worry. Okay. This is you must know. Okay, then again, what is the FC? FC is FC lah. You see from the equation. Okay, your FC is 100 hertz, 100,000 hertz. Okay, now new term is something like F upper sideband. F upper sideband equals to, this is new thing, FC plus FM. Okay, upper sideband. This one new. You must know. F lower sideband equals to FC minus F take out first. This is something like what you see last time in your video. Okay, video that I showed to you. Okay, so you guys see F upper sideband. So what is your F upper sideband? As what we already study. Okay, FC. What is your FC? 100,000, right? 100,000 plus what is your FM? Input frequency? 1,500. You add up, you got F upper sideband equals to 101 500 hertz. Okay. Then how about the F lower sideband? F lower sideband equals to 100,000 minus 1,500. Don't worry, this is first class. You don't understand, don't worry. After this, you will understand. Okay. So F lower sideband equals to, what's the value? Calculate lah. You want me to calculate? What is the value? 100,000 minus 1,500. What's the value?
98500.
98500.
Right, nah, this one. Okay, correct. Okay, so basically, wait, add more. Okay, add more. Add pages. So basically, how to draw? We draw back again. Remember, so telling something. This is frequency domain. Okay, what we call this figure is the frequency domain. Why frequency domain? Because this exists represent frequency. Okay, that's why we call frequency domain. Last time domain like this because time domain. This is time domain. Time domain. Why time domain? Because they exist represent by T. Here represent by F. Okay, understand or not? We go to your next slide. Understand or not this concept? So
Understand,
here
sir.
is your FC. This one F upper side band. This one F lower side band. F upper side band equals to 101,500 Hertz. Okay, and then FC, what's your FC? 100,000 Hertz. And then F lower side band equals to 98,500 Hertz. Easy. Okay. Now, one more thing. Settling something. Okay. How about the power? Okay, now this one finish. Frequency in terms of frequency. But in frequency domain, we also calculate. Let's say add more question. From this thing, here bandwidth. We can find bandwidth. What is the bandwidth? Bandwidth. You can prove. Okay, bandwidth can be proved using time domain, and also frequency domain. To check. Okay. Okay, time domain equals to what? If in time domain equals to 2 times Fm. Okay, so what is the Fm? Your Fm 1500 Hertz, right? Correct or not? 3000 Hertz your bandwidth. Okay, what is the function of bandwidth? Something like data. You can store data, more data. Okay, 3000 Hertz. Okay, how about the frequency domain? Let's say if we do frequency domain, we check bandwidth equals to F upper side band minus F lower side band. Okay, F upper side band 101,500 minus 98,500. Okay, press calculator. Is it same 3,000? Is it same?
Yes, sir.
Same or not?
3,000, sir.
Ah, 3,000.
3,000.
Yeah, that's why I'm telling you something. Easy or not the subject? Easy. Last time this subject a lot of student got A lah. Okay, in my class lah. The class I don't know. Okay, so same same. So now this, see, you can prove using time domain and also frequency. Why? Because T equals to 1 over F. That's why you can prove. Who can prove? Because T equals to 1 over F, F equals to 1 over T. No problem. You can do analysis in time domain. You can do analysis in frequency domain. No problem. Okay. Now, we finish on bandwidth. Okay, remember so telling you, okay, add one more, 8 pages. Okay, in frequency domain, that's what I mentioned to you, we also can describe in terms of this one frequency, right? These sets have upper side band, F carrier, F lower side band. Here also represent the power analysis, AM power. Okay, AM power. So what is the formula? Okay, right now, so just give you the direct formula first, and then you just remember first, and then later on we do some. I give you the derivation. Okay. Okay. So we got 2. Some of the students say, why is it 2? Wait, I told you. I told you some. After that, I told you. Here FC plus FM. Here FC. Okay, FC minus FA. This one can represent in terms of VC. VC, here is a MVC over 2. Here MVC over 2. Okay. So what is this, sir? This one represent in terms of voltage. Analysis of voltage. Okay. And as what I told you before, can also in terms of power. Power is here, PC. How about here? Here is M squared PC over 4. Here M squared PC over 4. Here same. FC, FC plus FM, FC minus FE. Okay. Can be in two form. Voltage, okay, voltage, and also power. Okay, clear? Already copy? Copy. Take copy, you must copy. Okay. No, not. Okay. You finish, tell sir, so that sir can move further. Okay. Finish or not? Copy. Dah habis dah salin? Belum? Dah. Slow je suara ni.
Dah.
Dah.
Dah, sir, dah.
Very
Dah,
good.
sir.
Basic. So telling something, oh my god. AM very easy. Okay. Now, after this, I akan recap balik. So, we'll recap everything. After 3:30, I will recap everything. Okay, now. We go to power. We go to power analysis. Okay, remember? Power analysis, remember? Okay, turn off your microphone tadi. Shashmita. Okay, thank you. Power analysis. Okay. For power analysis, remember? Related with frequency what? Frequency spectrum. Okay. Okay, now we go to the power analysis. Okay. Power transmit. Okay, here, power transmit equals to power carrier plus P upper sideband plus P lower sideband. Okay, before that, so I want to tell you something. In this figure, actually the height of for both of these things are same, same height, same. Okay, same. Okay, then what happened? PC is, okay, what is the PC? Okay, now you put PC here. And then how about P upper sideband? Okay, what is the M? M is the modulation index. Remember, what is the M? M is the modulation index. M equals to Vm over Vc. How you want to remember modulation index? Modulation index very important. You must remember something. Monkey is top of car, not car over the monkey. Okay, so remember modulation index Vm over Vc. Monkey over the car, not car over the monkey. So clear or not? How to remember the formula? Modulation index for AM, Vm over Vc. Okay now. So take here. Okay. So what this thing first? Okay. So power analysis, P upper is what I mentioned before. Upper sideband equals to M squared PC over 4. And then plus M squared PC over 4. Okay. So this one can be factorized. Okay. Not factorized, you add up. Okay. Here same, right? 1 over 4 plus 1 over 4 equals to what? M squared PC over 2. Correct or not? Oh my god, 1 over 4 plus 1 over 4, you don't know. Correct or not?
Correct, sir.
Correct, eh? So from here, very good. Okay. Don't worry, I'll recap back before we go further. Anyway, easy to missing now. Okay. This one. When we finish. Where is it? Missing. Wait, so also headache. Oh, here. Add pages. Okay, now. Okay, so PT equals to PC plus M squared PC over 2. This one can factorize, huh? PT power transmit, total power transmit for AM equals to what? If you factorize in terms of PC, you take out PC. This one 1 plus M squared over 2. Right or not? Factorize. Right or not? So this is new thing, you will know. Okay. Okay. Then last time you already know about the we got single double sideband full carrier. Okay, double sideband. Okay, this one I'm someone to telling something related with this analysis. Frequency spectrum. Okay, you will learn on the double sideband full carrier. Double sideband suppressed carrier. Single sideband full carrier, single sideband suppressed carrier, and then single sideband. Okay. So what is the difference of this thing? This thing can be, you can do analysis in terms of frequency spectrum. Frequency spectrum, where it related with power transmit. Total power transmit. Okay. So last time, double sideband full carrier. Double sideband full carrier. Okay, easy to see when you have in terms of frequency spectrum. Double sideband full carrier is a normal tradition pass. Okay. So here, this one FC plus FM. Here FC minus FM. Okay, for double sideband, normal formula PT equals to P carrier plus P upper sideband plus P lower sideband. Okay, for double sideband suppressed carrier. Suppressed carrier means you transmit without carrier. So it will be like this. Here. This one you throw away. So the power transmit for double sideband suppressed carrier equals to P upper sideband plus P lower sideband. Okay, understand or not this thing? Understand or not?
Understand.
Now you silent, so don't know. Very good, because you already last time you already see the YouTube. You write down something. Now so give you summary what you already see in YouTube, apa yang you nampak dalam YouTube you tu. Okay, ini sebagai summary. Seronok, this subject very very interesting. Okay, nampak saya tunjuk you tak payah ada slide semua. Okay, saya tak tunjuk pun slide yang apa ada because saya said you must understand first. Jangan pening kepala, you understand first apa yang berlaku pada chapter ni. Okay, lagi senang nampak. Okay, so double sideband suppressed carrier. Ini dah habis. Now kita tambah lagi satu lagi. Kita ada single sideband single sideband full carrier. Okay, single sideband. Single. Okay, masuk single. Apa masuk single? Single like this. Kita boleh jadi dua. Okay. Satu, you transmit here. Single sideband full carrier means full means you got carrier lah. Okay. Or okay. Here. So can be two. The first one, P total equals to P carrier plus in this case P lower sideband. Okay, or P transmit equals to PC plus P upper side band. Can be two. Okay, actually no problem. Actually, P upper side band actually same with P lower side band. That's why you see the height same. Okay, the height same. Okay. Now we go to single sideband suppressed carrier. For single sideband suppressed carrier, okay, you got like this. Okay. Okay, suppressed carrier means this one must check back. Wait, so must check back for it. Single sideband suppressed carrier, single sideband suppressed carrier. This one, double sideband full carrier. Okay, you got traditional one. You got a P upper sideband, P upper sideband, P lower sideband, P carrier, here P upper sideband. So double sideband full carrier. Okay, full carrier. Okay, and then double sideband full carrier, no problem. And then we got double sideband suppress. Okay, suppress I already told you. There's no carrier here. Okay, no carrier. Okay, double sideband suppress carrier. Double sideband suppress carrier. This thing. Double sideband suppress carrier. Means no carrier. Double sideband but no carrier. Okay, single sideband. Single sideband. Okay, here. Actually, we start here. Single sideband, as what I mentioned before, actually single sideband, we got two. Single sideband, full carrier, single sideband, suppressed carrier. Okay, now let's see. Okay, modulating. Single sideband. Okay, here they told you something like is single sideband. Actually, this one single sideband. This one single sideband. Suppressed carrier, I think. Single sideband suppressed carrier. Or they make you confused. So I make summary back. Wait, submit summary back. Okay. How the signal look like. Okay. Okay, here. Set more. So, repeat again. So, double sideband full carrier. The frequency spectrum like this. Okay. Double sideband suppressed carrier means no carrier. Okay, no carrier. Okay, suppressed carrier. And then single sideband full carrier. Single sideband full carrier means you include the carrier. Okay. Oh. Then you got single sideband suppressed carrier means no carrier. Okay. only this thing, or okay. And then we got vestigial sideband, VSB. Vestigial sideband like this. Okay, vestigial sideband, you got the signal. Actually, can be both lah. Okay, something like this. You got the signal. This one like this. Here half. Okay, half. Not same. The height not same. Or vestigial sideband. Put here lower. Not same. Okay, this is vestigial sideband. Okay, so you must know something. PC. Okay, now don't forget to tell you. So repeat again. Power transmit equals to PC plus P upper side band plus P lower side band. PC equals to VC squared over 2R plus the upper side band M squared PC over 4 plus M squared PC over 4. This one is the for double sideband full carrier. Okay, you just represent. For example, this thing, we transmit here become P upper sideband plus P lower sideband, something like that. Single sideband full carrier equals to we transmit equals to PC plus P upper sideband, or PT PC minus P upper sideband. P this one PT this one PT plus P upper sideband. Okay, don't worry. So just make your summary so that you will understand after this. Okay, don't worry. Easy. Okay, now. Okay, finish already. Now, we go to your slide. Mathematical expression. So give you example. Let's see example in slide. Okay, that one so will give so already give you example. So recap back. Recap back. Okay, here. So recap back. Amplitude modulation. Okay. Here you got introduction. Okay, introduction something like you know about the V input T, VC T, and then you got VAM T. Okay, for introduction. And then principle of AM, you got frequency domain, and also time domain. Okay, AM transmission technique. So here you will learn on power analysis. Comparison means single sideband, a double sideband, full carrier, double sideband, suppressed carrier, single sideband, full carrier, single sideband, suppressed carrier, vestigial sideband. Okay, this is what you learn. Okay, last time when you see your YouTube. Okay, now, so recap back. Some of you now we see the slide. Okay, now we see this. Okay, see? Okay, AM concept. So told you, amplitude modulation is the process of changing the amplitude of relatively high frequency. That's what's telling something. The frequency related with high frequency. Okay. And then information signal or input signal related with actually changing the high frequency signal in accordance with the amplitude of modulating signal information. Actually related of low frequency. Okay. It's a low quality form of modulation. Okay. Last time when you see the AM radio, you see something like have you already heard something like when you take your car, sometimes you press the wrong mode AM. What you will heard when you press AM. If you change to AM mode, maybe at home or in your car. Yeah? You heard something, people talking but not clear, correct or not? AM.
Yes.
Never test. So that one, low quality form of modulation, but there's the advantages to telling something. AM is not the bad at all. We got the best thing. Okay, the best thing, we can for long distance. Long distance. You can go for long distance. Actually, sometimes in Malaysia, AM radio using for the amateur radio. But in Malaysia, we don't have AM radio. We got only amateur radio, radio amateur. Okay. In Thailand, we got AM radio. This why sometimes you see they are talking, you don't understand, but you heard something they are talking. Actually, in Thailand, they are using AM. Okay. AM radio, normally we use the best thing of the AM radio for long distance. Okay. And then right now, AM's concept also apply in your apa tu, kunci buka kereta tu panggil apa? Your key card. Yang tu buka kereta tu, alarm ni apa yang kita buka kereta tu? Apa nama dia? Key card lah. Kunci kereta, you want to open your door. Okay, open your door, maksudnya for long distance, jarak jauh. Long time ago, you nak buka kereta kan, titit, you open the ni, you must nearby the dekat dengan kereta. Right now, when you apply AM, right now most of them are using AM, you can go for long distance. You tekan tit, maybe 500 meters, 700 meters. Clear? Okay. Now, so AM waveform like this. Okay, carrier as what I mentioned before. High frequency, the signal look like this. Low frequency, look like this. Okay. This is modulated. Modulated signal. Actually, this one replicate put here. That's why last time you see the introduction of AM, they're telling you actually this signal like this. Okay. Okay. AM waveform. Okay. Envelope is the original modulating signal. Okay. Original. Okay. This one information signal. Actually, this is your information signal. Okay. Here is your carrier signal. Okay. Okay, now this is the formula. Unmodulated signal. Actually, as what I mentioned before, this is the input. Okay, same. VI, VA, same. Okay. VM is a peak modulating signal amplitude. Okay. Now we go to the carrier. How the carrier like high frequency. That's why become narrow. Okay, narrow. So here is VC. Here is negative VC. Okay. And then how to do the derivation of the VAM? Actually very simple. VMT, okay, equals to VM sine omega MT. VCT equals to VC sine omega CT. Then how about AM? The representation of the AM something like this. VAMT equals to VM plus VC sine omega CT. Actually, this is the formula. Okay, for the signal look like this mathematical equation. Okay, VM. Not VM. VM plus VC sine omega CT. Actually, VC lah. Sorry. Actually here, actually here, don't worry, after this, when you see the example, actually no problem at all. Okay, because you can answer it very simple. Okay, wait, AB sine omega. Oh, okay. Betul lah. VC plus VM. Sorry, VC plus VM sine omega CT. Okay, it's okay. This is the formula for VAM T. Okay, it's okay. Now for this part, so don't want to explain first. Next class so we'll explain back. Okay, this one you add up in modulator. You got VAM T. For mathematical derivation, I show you next class, so that you don't get confused. Because actually mathematical is very simple. So today you don't have basic. I give you a lot of things, so I worry you don't understand. Okay, so basically, okay, that's what I mentioned you before last time. Okay, let's say last time I give you the example. Last time, what's the example I give to you? Just now I give you VMT equals to, last time like this, right? 15, and then here 60, right? 60. Actually, okay, the VMT, I repeat again, VMT equals to, last time I give you this problem, sine 2 pi 1500t VCT equals to 60 sine 2 pi 100,000 t. Okay, so how to draw? Actually, this is how you want to draw the AM signal. Okay, so here is Vmax. Actually, we call it as a Vmax. Vmax. Okay, Vmax means Vc plus Vm. So 15 plus 70, 60 equals to 75. So how to draw here? Here actually, we mean as this one Vmax, plus Vmax, this one negative Vmax equals to 60, negative 60 minus negative 15 equals to negative 75. So you got positive peak 75, negative peak you got negative 75. Okay, here you got Vmin. Actually, this here is Vmin, negative Vmin. Negative Vmin equals to negative C, negative Vc. Negative Vc equals to negative 60 plus 15. You got negative 45. Negative 45 here. That's why last time here Vmin negative Vmin, negative Vmin. Now positive Vmin equals to EC minus EM. So 60 minus 15, you got 45. So basically this is how you draw the ANC signal. Okay. Okay, mathematical next class I derive to you. Clear? Okay. Now, as what I mentioned before, Vm less than Vc. Modulation index, Vm over Vc, monkey on the car. This is Vm, percentage of modulation. What is this? Okay, Vm over Vc, monkey over car. I recap back what we already studied just now. M percentage of modulation index time 100%. Okay, and then this is new thing. M equals to Vm over Vc. At the same time, Vm equals to here. How to get Vm? Here. How to get Vm? Vm equals to Vmax minus Vc. That's why you got this thing. Vmax minus Vm equals to, you can take this thing, Vm, if you see the figure, Vm equals to, yeah, Vm, this one Vmax, okay, Vm equals to Vc minus Vmax. Okay. Okay, this thing I show you next class. Okay, I worried you become headache. Okay, so actually this is actually we got the simple derivation. I show you next class on modulation index for this part. Actually we got another form. This thing. Okay, the basic thing modulation index equals to m equals to Vm over Vc. This one I'll show you next slide, next class, so that you so that you faham, tak ada pening kepala. Okay. Efficiency. Okay, efficiency. Ni sebagai tahu tadi frequency domain. How you know? Ni frequency domain. Frequency domain. Ni. This one frequency domain yang saya telling you before just now. We got upper sideband, lower sideband, carrier frequency. Okay, calculation FC plus FM, FC minus FM. Okay, and then this one V lower sideband, V upper sideband. Remember, I already go. Okay, right now I'm telling you something. We can in term of, you can make in term of V, another one in term of power. Okay, don't worry. After this, I will summary back. Okay, so bandwidth in frequency domain, upper sideband minus lower sideband. In time domain, 2FM. So I already proved to you. Okay. Picture figure 1. Okay, this one. Okay, example 2, I will recap on next class. Okay, so for those who just coming or not absent, I will upload this video in YouTube. Okay, so basically, so we'll stop recording part 1 amplitude